Let's do another example. Okay, so first of all I want to find the eigenvalues. To do that I'll use the characteristic equation, and then I want to find the corresponding eigenvectors. Okay, so it's a two-stage process, so let's start by finding the eigenvalues. So all you got to do is write down the characteristic equation. So you need to solve the determinant of A minus lambda identity equals 0 for lambda. Okay, that's the way we've done them up to now. Okay. So what is A minus lambda times the identity? This equals 3 minus lambda, 5, 5, and 3 minus lambda. Look right? Okay, so I want to set the determinant of this equal to 0. So this is equal to, so remember how to find the determinant of a 2 by 2 matrix. So this is the determinant of a 2 by 2 matrix. So I want to take the determinant of this matrix. So this is going to be 3 minus lambda squared minus 25. And I want to set that equal to 0 and solve it. Now, you could multiply this out, FOIL it out, and collect your terms. But it's a little bit faster to solve it this way, because this is a perfect square. I can just move it over, and then I can take a plus or minus square root. So 3 minus lambda will equal plus or minus square root of 25, which is plus or minus 5. Okay, so if 3 minus lambda is equal to plus or minus 5, let's solve that for lambda, so let's move lambda over here and subtract this. Lambda equals 3 plus or minus 5. So lambda equals -2 or 8. Okay, now I need to find each eigenspace. So the second part will be to find the eigenvector of, let's start with lambda is -2. Okay, so what I have to do is I have to solve A minus lambda times the identity times x equals 0 for x. So remember, that's the definition of an eigenvector. Okay. So what is A? Okay, minus lambda times the identity is going to be plus 2 times the identity. So this is equal to A, which is 3, 5, 5, 3, plus 2 times the identity 1, 0, 0, 1. Okay. So this is 3, 5, 5, 3, plus 2 on the diagonal, which equals 5, 5, 5, 5. Alright? So I'm solving 5, 5, 5, 5 equals 0. Okay, when you row reduce that, what do you get? I'm still going to have 0 here, and I'm going to have a row of zeros down here. And then I'll divide by 5 to get 1, 1. Okay, now I can write my solution set. So I can say x is equal to x1, x2. Right? What's my solution set? Well, x2 is a free variable, and x1, this equation tells me x1 plus x2 is 0, which is the same thing as saying x1 is negative x2. So if x1 is negative x2, I'll plug that in here. I get negative x2 and x2. Factor out x2, and I get x2 times negative 1, 1.